Okay, question 3 of the photoelectric effect, which was taken from the February-March paper, so the supplementary paper from the Department of Education in 2009. They tell us the work function of 3 metals is shown below. So you've got aluminium, zinc, silver, and generally when they give you a set of things like this, it means we're going to have to compare them or make a decision or something about this. Then they say, give a reason why different metals have different work functions. It's all about the structure of the atom and how easy or difficult it is for electrons to be removed. Now, you would have learned hopefully in grade 10 that this is actually known as the ionization energy. So, different metals have different ionization energies. That's what it's about. So it's just that some metals that's terribly spelled. Let's write that again. There we go. Alright, so it's just because of their structure. Now they say light of wave 2,3 times 10 to the minus 7 meters. We like it when they give it to us in meters already. Is shone onto metal X. So we don't know what it is. The average speed of the emitted electrons is 4,78 times 10 to the 5. They then ask us to identify metal X by performing a relevant calculation. So basically what they're saying is find which work function it is. You need to calculate the work function of the situation that you've just got. So what they've told us is you've got lambda and you've got V. Now we know that E equals WO plus EK max. Now on our information sheet we also know that E equals HC over lambda, so that's what I'm going to use here because I have lambda. I'm not going to change WO because that's what I'm looking for, and I'm going to use a half mv squared. Substitute in 6,63 times 10 to the minus 34 times 3 times 10 to the 8. Lambda 2,3 times 10 to the minus 7. Oopsie, don't forget the WO. Oops, I was about to leave it out. WO plus a half 9,11 times 10 to the minus 31 times 4, I should have left myself more space. Okay, now it's a maths problem. I'm not going to go through all the maths, but what you end up with is that WO is about 7,61 times 10 to the minus 19. Okay, now it's not exactly 7,56, but it's close enough and it's a rounding issue. So when I look at it, it's closest to silver. That means X is silver. Done. What conclusion about the nature of light is drawn from the photoelectric effect? Light has a particle nature. Really quite straightforward.